All right, so we're continuing on our journey of deriving the C5h character table. We're getting fairly close here. What we did in the last part of the video was we were in the middle of breaking up this first component, E1 prime, getting these into complex numbers in terms of epsilon, complex characters here for a lot of these. And we got in terms of epsilon, which we used Euler's formula to figure out. Epsilon is defined, we're defining it as e to the 2 pi over 5I, which is equal to cosine 2 pi over 5 plus I sine 2 pi over 5 by Euler's formula. This is just a compact way to write it. This is epsilon squared, which ends up equaling e to 4 pi over 5I. And complex conjugate of epsilon squared was also useful, and epsilon squared. And so now we have to keep going through and deriving just this other vector here. And the easiest way to do that, this other component of the vector, is to call this a value a. We know that a plus epsilon is going to be equal to 2 cosine 2 pi over 5. Well, a is then equal to 2 cosine 2 pi over 5 minus, and the reason why we know this is we broke it up in the components, right? 1 plus 1 is 2. Whatever this value, epsilon squared plus whatever this value is going to equal to this character. So that's how, we broke it up. So that's how we know that the pieces must fit back together. So anyway, what is epsilon? We're minusing epsilon. Epsilon is cosine 2 pi over 5. And then we're minusing it, so minus I sine 2 pi over 5. And so that's going to be equal to, we just have 1 cosine 2 pi over 5 minus I sine 2 pi over 5. Well, that's just equal to what epsilon is, except the I component is negative. And that's the definition of a complex conjugate. So this A value is just equal to the complex conjugate of epsilon. And then we can do the same thing with epsilon squared. Well, epsilon squared, we know is equal to E4 pi over I. And we're going to get now 2 epsilon squared plus, some value b or whatever is equal to 2 cosine 4 pi over 5. So this value is going to be 2 cosine 4 pi over 5 minus epsilon squared. It's going to be a very analogous type of thing, but it's going to be now the complex conjugate of epsilon squared. Okay, and then if we think about doing that, subtracting off 2 cosine 4 pi over 5 minus cosine 4 pi over 5 minus I sine 4 pi over 5. We're going to get 1 cosine 4 pi over 5 minus I sine 4 pi over 5. Same thing as epsilon squared, except the I part is negative. Sorry, we started with a complex conjugate. So let's go through that again. Complex conjugate of this, right? Complex conjugate of epsilon squared is cosine 4 pi over 5 minus I sine 4 pi over 5. So anyway, we have 2 cosine 4 pi over 5 minus this. That gets us just 1 cosine 4 over pi, but minus and minus gives us a plus I sine 4 pi over 5. So we're back to epsilon squared. And then now we kind of figured out that epsilon plus epsilon complex conjugate equals 2 cosine 2 pi over 5. That's what we have here. So this one has to be an epsilon following the pattern. This one's going to have to be a 1 because we know x, y went to x. X and y went to both the same thing. X went to x, x vector went to x, y vector went to y when we're talking about horizontal mirror plane, which is in the xy plane. So the function x plus iy goes to x plus iy. Or, another way of saying this is just 1 plus 1 has to equal 2. X minus iy, in this case, actually this bottom vector is going to transform us. And then all these other ones, we have -1s. And so again, we just have to look here. All right, something, that was for a double prime, sorry, but something plus epsilon equals 2 cosine 2 pi over 5. That's the same situation we had over there. Complex conjugate of epsilon. Complex conjugate of epsilon squared is equal to 2 cosine 4 pi over 5. That's what we had over here. The answer was epsilon squared. Analogous thing here, 2 cosine of 4 pi over 5. So we get complex conjugate of epsilon squared. And this one equals 2 cosine 2 pi over 5, get epsilon. So that's how we could very quickly derive this bottom vector.